Okay, section 4.3 video, part 3. In part 2, I left off with giving you these properties, but we have not done anything with these properties. And so what we're about to do now is I'm about to give you some problems where I say use these properties to do what I ask you to do. So when we use these properties, we're going to be either using them from left to right or from right to left. Okay, take down these instructions. Use the properties of logarithms to rewrite the single logarithm. Okay, so because of the way those words were, the instructions was worded, I'm going to give you a single log, and we're going to rewrite it. So we're using the properties coming from left to right. Now you say, well, how do we know which property we're going to be using? I'm about to show you that. Okay, so let's look at, we're going to do 4 examples here. So look at this first example here. The log of x to the 5th, y to the 3rd. Now, let me ask you this question first. How many logs do you see? Only 1. Now, look at what you're doing in that parentheses. X to the 5th, and then what's this understood to be? Times y to the 3rd. So you are multiplying 2 things. Okay, look at your properties of logarithms. Do we have a logarithm property where you're multiplying 2 things? Yes, we do. The log of this times this is the log of the first one plus the log of the second one. So, in this problem, the log of this times this, that is like your A, and that's like your B. So we're going to take the log of the first one plus the log of the second one. The log of A times B is the log of the first one plus the log of the second one. Okay, now I want to expand this farther if I can. So we just use this property. Now, are we using this property at all? No, because you're not taking the log of a fraction. Now, look at this property. Are we taking the log of anything to a power? Yes. The log of this to that power. The log of this to that power. So, according to this property right here, the log of something to a power, what can I do to that power? I can bring it down front of the logarithm. So, I can expand this a little bit farther by bringing this power down front and this power down front. But I had to break it up first because of the multiplication. Then I use the power rule. So I use the first property, and then I use the power property. And you'll see when you're expanding it like we're doing right now, the power property is usually the last property you use. That property number 3. Okay, we can't go any further with it. I've expanded it as far as I can go. Now, in just a few minutes, I'm going to give you this problem, and we're going to reverse the steps. So what we're going to do is we're going to put the numbers back above, and then when you're adding 2 logs, we're going to put it back together as 1 log. So, but that's for a few minutes down the road. So, okay, let's look at this one. And by the way, I should have said this when I gave you the properties. When you wrote those properties down, if you'll notice, we didn't put a base. So if there's no base written, what is it? Base 10. But all of those properties hold true if the base is not 10. So if the base is not 10, we're going to still use the properties. You just have to write the base every time. It's a little aggravating, but the properties still work the same. Okay, so the base doesn't affect what property you're using. All right, look at what we're doing. 1 log a fraction. Okay, let's look back at my properties. One log a fraction. So what do? You take the log of the top minus the log of the bottom. The log of the top minus the log of the bottom. So what I would do here, the log of the top minus the log of the bottom. But you have to put the base 3 back. Now, do what we did up here. The log of something to a power, what can you do to that power? Bring it down. Power down, power down. So right here, this 3, I'm going to bring down front. This 2, I'm going to bring down front. So when I do, I get that. Okay, let's look at this one. Now, the one little tricky part to this one. First part's easy, though. Okay, the log of a fraction. How do you take the log, 1 log, don't worry with the base. How do you take the log of a fraction? You take the log of the top minus the log of the bottom. The log of the top minus the log of the bottom. Now this is where this one will get you if you're not careful. If you are not careful right here, you'll want to bring this 3 down front. And you can't yet. Here is why. What's understood between this 5 and that x to the 3rd? What mathematical symbol right there? Multiply. So you got to separate this apart before you can bring this 3 down. See, this is like the log of a times b, because you're multiplying 2 things. So you got to separate that out. That means you got to use that first property. What is the log of a times b? It's the log of the first one plus the log of the second one. So you have to separate that out first. So it's the log of the first one plus the log of the second one, because you're multiplying those. The log of a times b is the log of a plus the log of b. And then just bring that down. Now you can bring this power down front. You can bring this power down front. And this has a 1 exponent. Nothing to bring. You can't bring the 5 out front now. But the 1 exponent, if you put it out front, it's understood 1 anyway. So you can't do anything with this. But you can bring that power down and that power down. And that is as expanded, that's as expanded as far as it'll go. Okay, let's do one more here. The log of 3x to the 7th, 3x to the 2nd, plus y to the 7th. Now, let me show you what trap you'll fall into here on this one. You'll say the log of this one plus the log of that one. Now, remember, you have to use your properties of logarithms to work this. So, let me put the properties of logs back up. The log of A times B, the log of A divided by B, and the log of something to a power. Do I have a property that says the log of you're adding two things? No, I don't. And you say, well, yes, you do. No, that's on the right side, and the log is with each one separately. You don't have a property of logarithms where you're adding in that argument. See, here you're adding within the argument. There's no property. So that problem there could not be expanded. Now, I know I would not give you one like that, but the reason I put that up is so that I just want you to be aware that not every logarithm can be expanded out. Okay. Now what I want to do is I want to give you some problems where we reverse these steps. So I'm going to give you this, and we're going to go back to that. Or I'm going to give you this where you're subtracting, right here. I'm going to give you this, and we're going to come back to here. So we're going to put the powers back up. So now we're reversing the steps. So we're going to power back up. If there's any numbers in front of the logarithms, we'll power back up, and then we'll put it together as one log. So now we're using the properties going from right to left. Write these instructions down. Use the properties of logarithms to write as a single log. Use the properties of logarithms to write as a single log. So what I'm going to do is I'm going to give you the logarithms where they're already separated out, and we're going to go backwards and put it back together as one log. So we're using these properties going from right to left. Now once again, what we're going to do first is if there's any number in front of a logarithm, we're going to put it back up. So we're going to use this property first. Then we'll use one of these two, depending on if you're adding or subtracting. All right, so let's do this. All right, so we'll start out real simple here. Just a second, sorry about this. Let's look at this example right here. I know this should be example E. If you want to start over with A, B, C, since it's different instructions, why don't you just do that? Call this A right here. All right, so we're putting it back together. So we've got two logs. Okay, do we have any numbers in front of the logs? No. If I did, I'd put them back up, but there's not. All right, now look at what we're doing to the two logs. We're adding two logs. So find a property on the right side of the equal where we are adding two logs. And when you put it back together as one log, what do you do to that argument and that argument? You multiply them. So this was real easy. So when you put this back together, it's the log of P times Q. Now, no, you do not have to put that dot there. You could just put log PQ. But it's not log P plus Q. It's P times Q. All right. Let's do another one. Now, on this one, we've got a number in front of this log, a number in front of this log. So we're going to take this number, put it back up, this number, and put it back up. So we're going to do this in two steps. The first thing I'll do is that. Now, you're adding two logs. When you're adding two logs and you put them together, what do you do to these two arguments? You multiply them. So when you put this together, it's going to be 1 log log P3 Q7. Log P3 Q7. And no, you probably don't have to put those in parentheses, but I typically do. Now notice it's understood base 10. But if the base was 8 and this base was 8, this base would be 8. And you say, well, what if the bases were different? If they were different, you couldn't put them together at all. And they will not be. But these bases do have to be the same in order for you to put the logarithms together. Okay? See this next one. And by the way, if I added a third log, if there were 3 logs added together, there'd be 3 things multiplied together in there, not just 2. Okay, let's look at this one. You're subtracting 2 logs. Do you have a number in front of the log here? No, but I do here. So put this 5 back above the y. All right, when I do that, I get this. Now, we are subtracting 2 logs. When you are subtracting 2 logs and you put them back together, when I am subtracting 2 logs and I put it back together, I put the log of the first one, it goes on top, that argument, and the argument for here goes on bottom. So when I put this together, right here, it'll be the log, x has to go on top, y5 goes on bottom, but still base 7. Okay, one more here, and this will close out this section. Let's see if we got, yeah. All right, we got 3 log x plus 2 log y minus 5 log z. Okay, I'm going to put these 3 logs together as one. So you're using the properties going from right to left now. All right, so take this 3, put it back up. This 2, put it back up. This 5, put it back up. When I do, I have this. Now, I'm going to do this all in one swoop right here. All right, look at what we're doing. We're adding 2 logs. If you're adding 2 logs and you put them together, what do you do to that x3 and that y2 when you put them together? You multiply. But along comes this other log that we're subtracting. So when you're subtracting a log, what do you do to that? You divide by it. You put it in the bottom. The one that comes behind the minus, the one that comes behind the minus goes in the bottom. The one that comes behind the minus goes in the bottom. So it's going to be 1 log, not 3. 1 log, and you're going to multiply log this times this over that. That's how that's written. Now, you say, Ms. Rayner, what if I just put that Z5 under just the Y2? It would be the same. Mathematically, it's the same thing. So, and I don't think you have to put the parentheses, but it's just a habit I get into there. So. All right, so that completes this section. And so we've used the properties of logarithms. So we will now go to section 4.5, and that will conclude our entire topic on exponent rules. So we'll stop here. Next video, section 4.5.